This video is actually the first installment in learning how to use the method of completing the square to solve quadratic equations. So why this video? This video is just all about for us to understand why we do what we do when we start using the method of completing the square. So from the examples we are going to be solving now, we are going to be learning how to make a part of a quadratic equation a perfect square. So when we understand that, we will now be able to use this method of completing the square to solve quadratic equations, especially when those equations cannot be factorized. So this method of completing the square can be used. So this is for us to practice, and also for us to understand why we do what we do when we use the method of completing the square in solving quadratic equations. So this question says, what must be added to x squared plus 8x to make it a perfect square? So what do we mean by that? We are looking for, this is x squared plus 8x. We are looking for what should be done to this to make it a perfect square. So what do we mean by that? We mean, what do we add? What constants do we add to this part of the equation, this quadratic equation? Let's call that constant k. What constant do we add to it so that when we factorize it, it looks something like this: x plus a certain number, and then we square it. So what do we add to this to make it a perfect square like this? A perfect square is just when we get the square root, we get a whole number. Like when we get the square root of a perfect square, we get a whole number, something like 25, 16. So we are now looking at this expression. What do we add to this part of this equation to make it a perfect square like this? So how to get that is we, first of all, spread out this part. So when we spread out this part, we mean x times that certain number. Squared means it's multiplying itself. And when we do that, we're going to get x times x is x squared. X times n is plus xn. Plus n times x is plus xn or nx. Okay. And then x times x is plus n times n is n squared. When we collect like terms, that's these two, we are going to have x squared. Xn plus xn is 2. Let's say xn should actually be nx. That's a number with the unknown, plus n squared. Okay, remember we are looking at what do we add to this. That is, what does this constant become so that it will look like a perfect square. So we have our x squared plus 8x plus that constant k. Now we are going to be comparing coefficients of x. We're going to be comparing the coefficients of x from both sides of this equation. So we have 8 as the coefficient of x, just x, not x squared. The coefficient of x on this part is 8. The coefficient of x on this part is 2n. So we have that 8 is equal to 2n. And for us to get this number n, we have to divide both sides by 2. When we do that, we are going to find that n is equal to 4. Okay, we found that n is equal to 4. Now we are going to compare these constants. Remember, quadratic equation just looks like x squared, that is ax, and then this part, and then a constant. We're going to be comparing the constants. So the constant on this side, we called it k, and the constant on this side is n squared. Remember from here that n is 4, therefore the constant is 4 squared. And finally, the constant is equal to 16. Remember, we started by saying that when we add whatever k is to this equation, we are going to get a perfect square. Therefore, 16 must be added to x squared plus 8 to make it a perfect square. So our final answer is that x squared plus 8x plus 16 is going to give us a perfect square that looks like this part, which is x plus n, and our n is 4, right? Squared. So this is our final answer. We are going to add 16 to this part of the equation to make it a perfect square like this. So we are going to make some observations from this. The observation we are making is that what we added to this was actually half of the coefficient of this x. Half of the coefficient of x is actually what we added to make this, like half of it, and we squared it. Half of it was 4, we squared it, getting 16. And then on this part of the equation where we have this part looking like a perfect square in a bracket, we have it like that's half of the b part. So further examples we are going to solve are actually going to help us to get used to this method. Now let's look at another example. We have x squared plus 4. We are still asking that same question. What do we add to x squared plus 4 to make it a perfect square? Now let me use my rough work side. Like we learned from the previous example, all we need is, what do we add to x squared plus 4x to make it a perfect square? All we need to do is we are going to say the coefficient of x, which is plus 4, divided by 2, that is half of it, and then later we are going to square it. So half of this is 2, and it's a plus 2. And then we are going to square it to get 4. So all we needed to do is when we add 4 to this equation, we are going to get a perfect square this thing will look like this. So we have x, remember, plus 2, that is just half of this coefficient of x squared. So you can go ahead, pause the video and try out to see if this part will be equal to this part when you open up this bracket, when you spread the bracket. Now let's try out another example. We've been working with coefficient of x as even number. Let's say it's an odd number. How do we handle that? So let's have this example. X squared plus 5x, an odd number this time. What do we add to x squared plus 5x to make this expression a perfect square? We go ahead. The coefficient of x is 5. We are going to divide it by 2, and it's a plus 5. We divide it by 2 and then square it. So when we divide by 2, it's just 5 over 2. Like, we don't want to go into fractions now. And then when we square it, it's equal to 25 over 4. So what we add to this part is 25 over 4 to make it a perfect square that would look like this. Now, for us to get what we'll add to this other part is we just look at this part before we got the final answer to add to this other part. So we have 5 over 2 plus 5 over 2 squared. And if we really wanted to, we can't leave our answer like this. It's not like we have to get it to proper fractions. So to get it to proper fractions, we'll now have x squared plus 5x. 25 over 4 is actually 6 whole number. 1 over 4 is equal to x plus 2 and half. So this is now when we open up, when you want to open up this part to get this part, always work with improper fractions, like they're easier to handle when you're calculating things. Now let's work with another example. Let's say it's a fraction that is on this other part. How do we handle it? We have this example, x squared plus 1 over 4x. What do we add to this expression to make it a perfect square? We still go over. We have our coefficient of x as 1 over 4. We get the half of it. That is by multiplying by half. It's easier to work this way when we deal with fractions. We get half of this fraction by multiplying by half. And when we multiply by half, we have to square it. So we have 1 times 1 is 1. 4 times 2 is 8. So this is what we are going to square up. This is the half of this 1 over 4. We are going to square it to get 1 over 64. So what we add to this part of the equation to make it a perfect square is actually 64. And the perfect square would look like this. X plus 1 over 8. We square it. Okay, so let's solve more. Let's say we have x squared minus this time 2 over 3x. We've never worked with minus before. So how do we handle this other example? So same way, we go over to our rough work side. We have minus 2 over 3 as the coefficient of our x. And we get the half of it by multiplying by half. And then at the end of the day, we are going to square it. So when we solve the bracket, we're going to get minus 2 over 6. That is minus 2 times 1 minus 2 ahead. 3 times 2 is 6. And then we will square this, right? When we square, we are going to get 4 over 36. So this 4 over 36 is what we add to this expression to make it a perfect square. And the perfect square will look like this. X, remember, whatever sign is here, that is here should be here. That's minus 2 over 6 squared. So this is it. You see, it's easy to handle, right? You just get this coefficient, half it, and square it. You add up the half that has been squared to this part of the expression to make it a perfect square. And that perfect square will look like just half of this coefficient of x. Now let's solve one more before we go. Let's solve one that has a mixed fraction on this part. Let's see how do we handle getting the half and the square of the mixed fraction of the coefficient of x. Okay, we have this example. That's x squared minus 4 whole number 2 over 3x. What do we add to this expression to make it a perfect square? Fine, we go on ahead. This is the coefficient of x, minus 4 whole number 2 over 3. Now, like I said, okay, that's minus 4 whole number 2 over 3. Now, like I said, it's easier to work with mixed fractions when you have to multiply, add, do anything to mixed fractions. It's easier to work with improper fraction of that mixed fraction. So we are going to get this to become an improper fraction. How do we do that? 4 times 3 is 12 plus 2 is 14. So we have 14 over 3 as this fraction is equal to 14 over 3. Remember, it's a negative value. So this is what we are going to have. When we have it, we are going to square it. So as to add it to this. So the half of this, 14 times 1 is 14. Remember, it's minus 14. 3 times 2 is 6. So this is what we are going to be squaring. When we square that, 14 squared is 196 and 6 squared is 36. So this is what we are going to be adding to this part. 196 over 36 should now be equal to x. Remember, it's minus 14 over 6. 14 over 6 squared. And of course, you don't leave your answer as this improper fraction. Get it to a proper fraction. Now, when we reduce to the lowest, like when we get this as a proper fraction, we are going to have it in this manner. X squared minus 4 whole number 2 over 3x plus this will now become 5 whole number 16 over 36 will now be equal to x minus 2 whole number 2 over 3 squared. And remember, this, no, 2 over 6, these fraction parts are not yet reduced to its lowest terms. So in math, we have to solve to, we get to the lowest terms. So we have x squared minus 4 whole number 2 over 3x plus 5 whole number. When we reduce this by dividing through by 4, we're going to get 4 over 9 is equal to x minus 2 whole number. This becomes 1 over 3, 1 over 3 squared. So this is our final answer. Remember, this one is just a mathematical problem, not really the completing the square issue. And that reminds me, this one, we didn't reduce it to the lowest tens. How can we leave something like this? We didn't reduce the lowest tens, so we have it as x squared minus 2 over 3x plus the 1 over 9 is equal to x minus 1 over 3 squared. It's now jam-packed, looking so crazy. But always get your answers reduced to the lowest terms. And remember, practice, practice, practice. Will make you get used to this method and see it's really nothing.